In this module, we show how to design, execute, and supervise Kubernetes jobs. When the agent first connects to the engine, several jobs object templates are created, each with a different purpose. To tackle this topic, we'll use the main templates, run job, which executes processes inside of Kubernetes and then allows supervision and generates job reports. We'll look at the various pages and fields specific to the Kubernetes jobs object. We need to reference the connection to submit to the right cluster, the namespace field, the cleanup function, and a couple more things. We'll then perform a full design demo to show the pages and fields we mentioned in the previous point. We'll submit the job to the system, supervise it, retrieve the successive statuses, and finally look at the job report generated by the execution. Install and connecting the agent generates the three main jobs object templates. The first one is the run job. Its role is to submit processes to the Kubernetes namespace. The design of this job entails setting one of four definition types based on your intentions, either YAML, JSON, a job stored externally in a file, or a process submitted from source control repository, say GitHub. The second one supports command submission. You can execute commands as long as they're interpreted by the operating system hosted by the pod. The third type is the scale deployments. You can target any application in a given pod and scale up or down by replicating or removing pods, hence increasing or decreasing and ultimately fine-tuning the environment based on your needs, say processing power or available resources. Irrespective of the job type, you'll need at least one connection object. You should always add the Kubernetes agent in the attributes page. Finally, for regular submissions, you should always consider the need for cleanup. When Automic submits processes to Kubernetes, the integration generates a number of items in the environments, like job traces and logs. Cleanup will remove these residual elements and leave the cluster the same way it found it. Let's start with YAML, JSON, and file job definition, since they're the most straightforward. You need a connection object to connect to the cluster and specify the namespace where the job is to execute. The two types, YAML and JSON, are the supported formats, and you simply copy and paste the code of the job in the job definition field. The definition contains a job name, which should be reflected in the job name field. If you wish to submit from a file, then this file must be present on the agent system. You indicate the path and the name. The fourth run type is comparable. It's intended to submit from a source control management platform, like GitHub, if it's secure and authentication is enforced. Like its counterparts, it requires a connection object, which references the SCM URL instead. A second connection object is required for authentication. The job definition field contains the name of the asset as a full URL. It should be clear that the SCM connection has absolutely no relation to the K8s connection object. We proceed with demos of the design and submission procedures. Later, we'll explain the other two types, execute command and scale deployments. We head to the folder that contains our jobs objects and create a new run jobs. Let's start with attributes, namely the Kubernetes agents. We enter the connection object to the appropriate cluster and click Browse to see if we can access the namespaces. For our purposes, we'll select the default namespace. Note that you could also type the namespace in the field. We select the YAML format and paste the code of our job. The job has a name which should be reflected in the matching fields. We also check cleanup to make sure that the remaining traces of the job are eliminated. Finally, we set the activation to never so that we can manage our job and process monitoring. Obviously, this isn't something that we recommend in production, but you can use this for testing. We execute, supervise the job, and look at the engine and agent job reports. Let's take a quick look at the other two job definition types. Instead of submitting the job directly on the form, you can reference a file in the file system. This file must be present on the agent host. You can submit from a source code manager. There's very little difference. The process is essentially the same. The main distinction is the second CONN, where we specify the SCM CONN objects, which stores authentication. Note that the basic connection should reference the SCM URL and credentials to the Kubernetes cluster hosting the SCM. The second job type is execute command. This gives us the ability to submit system commands inside the namespace. This is the Automic equivalent of the kubectl exec-it command. You find two fields, label and field selector. These provide the ability to target specific pods by filtering on labels or fields. The kubectl get pods command with the show labels option produces the list of pods and fields, name, read, status, and so forth, as well as all the labels assigned to those pods. You can type in the information in either fields, say metadata.name equal, and the name of the pod, or the label equal and the value name, and the command executes in all of the pods that match that label. The next type is the scale deployment job. This is really straightforward. You select the cluster, the namespace, and then browse the list of deployments, which is the list of applications currently running in the cluster, as well as the number of pods dedicated to each. You can easily increase or decrease this number based on a resource allocation, processing power, or something else by typing the desired value in the scale fields. In our example, Prometheus currently has 0 dedicated pods. We increase it to 3. Finally, we should consider variables. Most of the job type pages include a variable field, which can include JSON formatted variables. In our example, we've replaced the version of Perl with a variable called version. In the variables field, you can set the value of that variable and pass it that way so that the original script isn't modified. But you can take this a step further and use the variables and prompts page. Instead of passing a hard value, you can substitute an Automic variable with the usual ampersand and hash symbols and use that in the JSON message instead. Then in the variables page, set the value or values that you want. This provides the added benefit of not having to alter code elements. Values are managed via the Automic UI instead. At execution, those values will be submitted at runtime. Note that this only works with a YAML or JSON job definition type. You won't be able to pass values to a file.